Okay, so here's part B. What do we do when it gets a little more complex? Now on number 6, this is the first time we've had a leading coefficient that's negative. So we're going to pull out the negative and change the signs. But the negative or the minus 3 at the end, we're just going to scooch over a minus 3. So it's going to look like this. Negative on the outside, x squared minus 6x. We'll subtract the 3 over there. Same policy, negative 6 divided by 2, negative 3 squared is going to give you 9. So I'm going to add 9 inside my trinomial, but I actually subtracted 9 from this equation. So I'm going to add 9. Again, you want that net change to be 0. Just factor your trinomial, bring the negative down, x minus 3 quantity squared, negative 3 plus 9 would give you a positive 6. Your vertex here is going to be positive 3, positive 6. Okay, now the next two are fraction city. Number 7. F of x equals negative 3x squared. So now we have everything going on. We have a leading coefficient other than 1. We have a negative plus 4x minus 1. So you can kind of see where this is going. I have to pull a 3 out of a 4, and that probably won't be pretty. So pull out the negative 3. You're going to be left with x squared. When you pull out a negative from the positive 4x, your sign has to change. You're really dividing 4 by 3, so you're going to have 4/3 x as your middle term. If I were to redistribute this, my 2 3's would cancel. My negative times a negative would give me a positive 4 at the end. It's a little confusing. You can rewind the tape if you need to, and then take your negative 1, scooch it over to the side, minus 1. Now if that wasn't hard enough, now what we have to do is take that middle term, negative 4/3, and instead of thinking of it as divide by 2, I want you to think of it as multiplying by a half. I think that math is a little easier. Dividing by 2 is the same process as multiplying by a half. Cross-reduce your 4 and your 2, so now you have negative 2/3. And then when we square negative 2/3, we should end up with 4/9. Okay, so for my perfect square trinomial, I want to add 4/9. But here comes the tricky part yet once again. I'm not really adding 4/9. I subtracted negative 3 times 4/9. Now since this value is a negative, when I come over here, it's something I'm going to add to the negative 1. So I'm going to add 3 times 4/9. I apologize, it's getting a little small and they're like on top of each other here, but we'll simplify it in 1 second. Okay, when we go to graph or factor the trinomial, you bring down your negative 3. X is always first. You square root the last term. It's 2/3. You have to figure out whether it's plus 2/3 or minus 2/3. Well, since my middle term is subtracted, I know it's going to be minus, and this quantity is squared. Okay, well that's not so bad. I'm going to break this down into a couple different steps because it looks so small right now. So it's negative 1 plus 3 times 4/9. You can cross-reduce your 3 and your 9, and then you've got 4/3 on the bottom. So now what you're going to try to do is add negative 1 plus 4/3. I'm just going to bring down the equation, negative 3, x minus 2/3 squared. Now 1 is the same as 3/3, and I would like to get a common denominator. So if I have negative 3/3 plus 4/3, that'll simplify to 1/3. So final answer, negative 3 times the quantity x minus 2/3 squared. And again, 4 minus 3 would give you a positive 1/3 on the end. Your vertex here is going to be a positive 2/3, 1/3. There's a lot going on there. That's probably about as bad as it gets. We'll look at one more just like that, and then we'll be done. So number 8, g of x equals negative 5x squared plus 6x minus 1. Again, this is about as bad as it's going to get because when you pull the 5 out, 6 is not divisible by 5. So you're going to have a fraction in the middle. And it's negative, so you have to worry about sign changes as well. So let's pull out the negative 5. It's going to leave us with x squared. We have to change our sign because if we redistributed, we'd have to get a positive. We're dividing 6 by 5, which you really can't do, so you're going to be left with 6/5. This whole number 1, we're moving over to the side. Okay, we take that middle term, we multiply by a half, and we square it. So I have negative 6/5 times a half. I like cross-reducing first. 2 goes into 6 3 times. So now I have negative 3/5, and now I want to square negative 3/5. Yeah, I get a positive value, 9/25. So before I do anything too difficult, I'm just going to add 9/25. But the net change to this side of the equation is a negative 5 times 9/25. So when I go to add the term back in, it'll be a positive plus 5 times the quantity 9/25. And let's squiggle that so the computations don't get mixed in. Okay, I'm going to factor it. Bring down the 5. Don't think too much about it because you know you just square root the last term. The sign has to be negative. Square root of 9 will give you 3. Square root of 25 will give you 5. If you wanted to check your answer, you square the first term, you'd get x squared. You square the last term, you'd get 9/25 positive. But to get that middle term, you multiply these two together, and you multiply it by 2 because you'd have 2 of them if you were foiling. So I would have 3/5 x plus 3/5 x. Both of them would be negative. It would give you a negative 6/5 x. Oh, that's a mouthful. Okay, last step is to try to simplify the ending. So I would cross-reduce 5 and 25. 5 goes into 5 once, 5 goes into 25 5 times. So now I have negative 1 plus 9/5. Negative 1 is the same as 5/5 to get your common denominator. So minus 5/5 plus 9/5. All I did was try to get a common denominator there. And then your last step. Negative 5. Bring down your x minus 3/5 quantity squared minus 4/5. So your vertex value here, positive 3/5, positive 4/5. And that's pretty much it.